welcome to the Maths Master Masterclass. We continue with Financial Mathematics, grade 12, but then we're going to recap a little bit, grade 11, and then move straight to grade 12. So now let's look at the first formula in grade 11 that we're given. We have a formula of a simple interest. So this is a formula of a simple interest. And then the second formula, it's a formula of a simple decay. It's a simple decay that we've covered in grade 11. And then we have a compound interest. With a compound interest. And now again we have a reducing balance method. Reducing balance method. We have a reducing balance method, or you can also call it a depreciation. So now in this case, we know that our value of A, it is what we call the final amount. It's what we call the final amount. And then we have P, the final amount, and then we have P, which we call a principal amount. Principal amount, or you can call it a initial amount, the initial amount that was invested, right? Okay, so now, and then we also have I, we call an I an interest rate, call it an interest rate, and then we have N, which is called a period, right? So this is what we've covered in grade 11. We're just doing a bit recap of where we're coming from. So now, with a nominal and effective interest rate, we're going to have a formula which says 1 plus I, the new interest rate, and the period, into 1 plus the I, the nominal interest rate, with what? With the period also. So in this case, this formula will help you to convert the interest rate compounded quarterly to monthly, or compounded monthly to quarterly, or annually to semi-annually. So in that case, for example, if we were to convert from monthly to quarterly, then we are gonna have 1 plus into the new interest rate, which is what we are looking for, compounded quarterly, then divided by 4, and then we're gonna have N to be equal to 4, and then we'll have 1 plus the I, the nominal interest rate, divided by 12 to the power of 12. So now in that case, now you can, your nominal interest rate, it can be given. Suppose it was 8.6, then you're going to substitute 0.086. Then in that case, now you can look for what? You can now look for your new interest rate. So now let's look at the first example. So now in grade 12, we're going to use a compound interest in most cases, and also the depreciation or reducing balance. But however, now in grade 12, they're going to look for the value of N, which we can call it a period or number of payments. So now let's look at this example on finding the value of N. So now in this case, an amount of 10,000 rand, is invested with 6% per annum, and then it's compounded annually, right? So now we want to know how many years will it take for the investment to grow to 13,382.82. So now we're going to use the compound interest to calculate for the value of P. Then we have 1 plus I to the power of N, right? And it's compounded annually, meaning we're not going to multiply by N by anything or divide the interest rate. So we're not going to do that. So the initial amount, or the principal amount that was invested initially, which is P, that will be 10,000. So that is the initial amount that was invested, plus into 0.06. That's your interest rate. You're going to divide it by 100. Then now that amount of money, we want to know how long did it took for it to grow to 13,000. That is the principal amount. That is the money that we have accumulated after certain number of years. So now we have 13,382.26. So now let's look for the value of N. So solving for the value of N, the first thing we're going to do, we're going to divide both sides by 10,000. Divide both sides by 10,000. Then now in this case, we're going to divide by that, and then then in that case now you will have to press your calculator. Then there we go, you have 13,382.26 divided by 10,000. Then you'll get, let's divide, then you'll get 1.338226, which is equal to into 1 plus 0.06 to the power of n, right? So now we can look for the value of, we can now substitute and look for the value of n using logarithm, right? So now we're going to have n, to be equal to log into 1 plus 0.06, and then that is our base. Then we have 1.338226, right? And then our n will be equal to what? Let's press our calculator. Then log 1 plus 0.06 into 1.338226, then that will be 5 years. So it will take 5 years for that 10,000 compounded annually at the interest rate of 0.06 to be 13,382 26 cents. So it will take 5 years. So now that's how we find our value of n. You're going to use logarithm. Let's look at the second example where a company plans to invest 50,000. So they're planning to invest amount of 50,000. That is the principal amount, and then into an account that earns an interest rate of 8% per annum compounded quarterly. So now it's compounded quarterly, meaning the interest again quarterly into that investment account. So now we want to know how many years will it take for the investment to exceed 120,000. So how long will it take? Then we're looking for what? We're looking for the value of n, number of years, the period. So let's go back. So you have invested 50,000, that is a equal to p, compound interest to the power of n. So now the principal amount, the initial amount that you have invested, that will be what? That will be 50,000. Then you will have 50,000 in this case into, then you'll have 1 plus, and then your interest rate that you earn quarterly, that will be 0.08. You divide 8 by 100, then you will get 0.08, and then it's compounded quarterly. Therefore, you're going to divide your interest rate by 4, and then you will have to the power n. So now the amount of money that you will accumulate in certain number of years, which we don't know, we need to solve for, it will be 120, which is the money that you're going to accumulate. Then we'll have 120,000, and then now you can solve for the value of n. Solving for the value of n, now the first step, you divide both sides by 50,000. 1, 2, 3, 50,000, 1, 2, 1, 2, 3, and then the 50,000 will divide, and then we'll work out the 120,000 divided by 50,000. Then we're going to get 2.4. So in that case now, we'll have in that case now, we'll have 2.4 to be equal to, 1 plus 0.08 to the power of n. So now we can apply logarithm. Then our n will be log the base, which is 1 plus 0.0 divided by 4, 0.08 divided by 4. Then you close the brackets, then we'll have 2.4. And use your calculator there. Then let's see how long will it take for your 50,000 invested to be 120. How long will it take to be that? So we have 1 plus 0.08 divided by 4. Let's fix this. Okay, divided by 4. It's compounded quarterly. Therefore, that's why we're dividing by 4 the interest rate. And then you have 2.4. And then let's see what you get. Then your N will be 44. So that will be 44.21. So for you to get for you to invest 50,000 at interest rate of 0.08 compounded quarterly, it will take you 44 quarters to get 120,000. Right? Okay. Let's look at another example based on that. So now Sipho bought an ice cream machine. Let's highlight, very important. Sipho bought an ice cream machine that depreciates at 17% per annum on the reducing balance method. So now it's 17% per annum on the reducing balance method. So now, what does the reducing balance method tells us? The reducing balance method, it tells us about A, that is equals to P plus subtract the interest rate to the power of N, right? So now let's continue with the statement and understand what is required of us. So now we want to know how long, right? How long, that is the period, right? Will it take for the value of the ice cream to depreciate to 25% of the original price. So now in this case, what they're trying to say is we're looking for the value of N. Yes, we know we're looking for value of N, which is what? Which is the period. How long will it take? But however, how long will it take to do what? How long will it take the ice cream machine to depreciate at 25% of the original price? What is the original price? The original price in this case is P. So now we want to know how long will it take for this P to depreciate to what? To 0.25 of P, which is the original price, 0.25 of the original price. When it is what? When it depreciates at 17% on the reducing balance method. So now the principal amount, or the original amount, which is the principal amount, it's P. And then now we want to know how long will it take for that P to be 0.25 of the original amount, which is P. So now let's work it out. We're going to substitute. Then we'll have A to be equal to P into P, which is equal to interest rate to the power of N. So now the amount that we're going to get in the future, it depreciated by what? By 0.25. That will be what? That will be our final amount, which is going to be 0.25, which is equal to P, 0.25 P, sorry, because it's 0.25 of the original price. Then we have one subtract, and then the interest rate is 0.17 compounded annually. And then now we'll have our N. So in this case, now we can solve for the value of N. Solving for the value of N, now we're going to divide both sides by P and this side by P. So in this case, we'll have this divided by that and then this divided by that. So what are we remaining with? We now have 0.25 to be equal to into 1 subtract 0.17 to the power N. So now we can solve for N using logarithm. Then we'll have log equal to log base 1 subtract 0.17 into 0.25. So now you can press your calculator from there to find the value of N. Then in that case, we're going to have 1 subtract 0.17 into 0.25. Then that will be 7 years. So then we'll have 7.44 years. So for the it will take 7 years for the original price of P to depreciate by 25% of P, which is the original price. So it will take the period of 7 years, 7.44 years, right? Okay, so now focusing on future value, let's go to future value. Focusing on future value, we'll be talking about investments. We'll be talking about retirement annuities, and also we'll be talking about sinking funds, right? So now this is given the formula of a future value. So in this case, suppose we'll be talking about investment. There's this person who now consistently every month for the period of 5 years investing in money. So we want to know at the end of 5 years how much is this person going to have if the bank gives him the interest rate of, for example, 5.2%. So now, okay, let's look at that. And then based on sinking funds now, we know that you are in a situation now, you have a car and you want to buy a new car, but then now by selling your old car now, you are unable to purchase that car because you can afford it. But however, that outstanding money, you want to save it. That's what we call a sinking fund. By saving that amount of money, you'll be consistently saving money into account. So it's the money that you put aside for a certain purpose. That is what we call a sinking fund. So, okay, let's look at this formula. We have F, which we call it a future value. Future value is the amount of money that you're going to accumulate after some certain years. And then we have X to be what we call a monthly installment. That is a monthly installment. And then we have I, that is what we call an interest, rate. And then we have N, which we call period, or you can say number of payments. Okay, that is what we call number of payments. So now let's look at an example based on that. So example number 1, Zanel deposit 1,500 per month into the account that earns a 10% interest rate compounded monthly for the period of 8 years. So now we want to know what is the value at the end of this 8 years. So now we're going to write your formula, future value, which is equal to X into, then you'll have 1 plus your interest rate through power n subtract 1. Then you divide everything by interest rate. So what is the monthly installment? The monthly installment, that is your value of X. So Zanele was depositing 1,500 every month. 1,500, then we'll have into, then 1 plus the interest rate, that will be 0.10, and then that is compounded monthly. You will divide that by 12, and then now what is your N? Your N is number of payment that you have made. The number of payment that Zinto will make on this account, that will be 8 multiplied by 12, then subtract 1, and then everything you divide by interest rate. Then in that case, you'll have 1,500 into 1 plus 0.10 divided by 12. Remember, we're dividing by 12 because it's compounded. It's compounded monthly. Then now you'll have to the power of 12, and then 8 times 12, that will be 96. Subtract 1, then you divide everything by the interest rate, which is 1.0 divided by 12. So this interest rate we're supposed to substitute it there, but however, it's no problem, we've substituted it. Okay, so now let's work it out. We have 1,500 into, and you open the brackets, 1 plus 0.10 divided by 12, and then you close the bracket again. You'll have to the power of 96, and then subtract 1. So you divide by the interest rate, 1.10 divided by 12. It's compounded monthly, and then you will Zanele will have 219,271.61. So this is the amount of money that he's going to accumulate after a 8-year period if he invests 1.5 every month at an interest rate of 10%. So now this is the future value. That is the value that he's going to, that is the amount of money that she's going to get at the end of 8 years, right? Okay, let's look at the second example. A person wants to save 200,000 in a 5-year time. The account earns a 9% per annum compounded monthly. So now, how much must they deposit at the end of each month? So in this case, now this person wants to have 200,000 at the end of 5 years, right? So now the bank says, no, we'll give you the interest rate of 9% per annum compounded monthly. And then now he wants to know, how much must I deposit every month so that I can get that amount of money? So now that future value, we know the future value. He wants 200,000 in the future. And then, but what we don't know is the amount of money that he must deposit every month so that at the end of 5 years, he can have that amount of money. So now what is the future value? That will be 200,000, which is equal to, and then the value of X, that's what we're looking for, the monthly installment, and then into, then we'll have 1 plus the interest rate, that is 0.09 divided by what? Divided by 12, because it's compounded monthly. And then we'll have N, number of payments or the period, that will be 5 years, multiply by 12, it's compounded monthly. And then subtract 1, divide everything by what? By 0.09 divided by 12. So now in this case, now we are looking for what? We are looking for the value of X. So now we can say X, which is the monthly installment, that will be equal to 200,000, and then you divide by everything on the other side, you divide by this. So now in that case, now you're going to have what? You're going to have, by dividing by that, then you will have, okay, let me do this. So you're now going to divide by this, going to divide by it. So now you'll have what? Oops. Okay, now you'll have into 1 plus 0.09 divided by 12, and then to the power 5 multiplied by 12, that will give you 60. Then you'll have 60, subtract 1, and then everything divided by 0.09 divided by 12. So by doing that, then you will be able to find what? To find the value of X. Let's press the calculator and see what is the value of X. Okay, so we have 200,000 divided by into 1 plus 0.09 divided by 12. Close the bracket to the power of 60, and then subtract 1, and then you close the bracket again, and then that is divided by 0.09 divided by 12. So this person's monthly installment, which is the value of X, must be equal to, that must be what? That must be, he must pay 2,651.67 every month, so that he can accumulate the amount of 200,000 in a 5-year time if the interest rate given is 9% per annum compounded monthly. Okay, now let's look at another example. A person deposits 300,000 immediately. So highlight this immediately. It's very important. This person deposits 3,000 immediately, and then at the end of each month, for 3 years, and then at the end of each month for 3 years into an account earning 12% compounded monthly. So now we want to find the future value. So this person deposited 3,000 immediately into the account, and then each and every month now he deposited the amount of 3,000 into an account. So what does that tell us? It tells us that number of payments it has been affected. This person will be investing money for 3 years compounded monthly. That will be 3 times what? That will be 3 times 12, right? So now that will give us what? That will give us 36. But in this case, this person immediately deposited money, which is the first, which we can say it's initial payment, or the deposit. That is the deposit that he deposited into the saving account. That will be plus 1. Then we will have the total N of 37. Right, so now we can use the future value to determine the amount of money that he's going to accumulate. Then we have X into, and then we'll have 1 plus the interest rate to the power N, subtract 1, and then divided by what? Divided by that. So now our n has changed. It will be 37 due to the immediate deposit that was made by this person. So now we have x equal to, and then we'll have the monthly deposit that will be 3,000, and then into, oops, okay. So now we'll have x, which is 3,000, that's a monthly deposit, and then into 1 plus the interest rate given by the bank, 0.12, compounded monthly, then we divide by 12, and then to the power what? So power 37, then subtract 1 divided by interest rate, that is 0.12 divided by 12. Then what is your interest rate? Press your calculator. Let's see what we get. And in this case, we have 3,000 into 1 plus 0.12 divided by 12, and then that will be to the power 37. That means that he has to make 37 payments, that he will make 37 payments, right? Okay, then you divide by interest rate, which is 0.12 divided by 12. So at the end of 37 payment, this person will have an amount of 133,522.94. So this is the amount of money that this person is going to accumulate. Okay, so let's look at another example. Okay, this is based on the test that was written in Amajuba district in 2025, right? So now after completing his studies, James decided to save money to buy himself a car for cash, right? He wants to save an amount of what? Amount of 300,000 by making monthly equal deposit into the saving account. Okay, that pays an interest rate. It pays an interest rate of what? Of 8%, compounded monthly, and then that should be done over the period of 7 years. So now we want to know how much must he deposit? What is the monthly installment that he must deposit in order for him to achieve that 300,000 compounded monthly at an interest rate of 8.6 for the period of 7 years? Okay, so now we go back to our formula. We'll have future value, which is equal to x into, then we have 1 plus the interest rate to the power n, number of payments, then we have divided by that, and then we have interest rate, and then the future value that we want to accumulate, that is 300,000. Then we'll have 300,000 to 3, which is equal to, we're looking for monthly installment, then we'll have okay, let me do this. We'll have x, which is the monthly installment. Here is I. We have monthly installment, that will be into 1 plus the interest rate, that is 0.0886 divided by what? Divided by 12, because it's compounded monthly, and then to the power of n. And then what will be our n? Our n will be 7 multiplied by 12, and then you subtract 1. And then the interest rate in this case will be what? Will be 0.086 divided by 12. So now the same way we do it. So you're going to say x, which is a monthly installment, that will be equal to, and then 300,000. You take your 300,000, then you will have 300,000, and then you divide by what? You divide by everything. So everything we're talking about this, going to divide by that, right? So now you're going to divide by into, then we have 1 plus 0.086 divided by 12 to the power, and then you'll say 12 multiplied by 7. 12 multiplied by 7, that will give you 84. And then you subtract 1, and then you divide everything by 0.086 divided by 12, right? Okay, due to space, but however, different color worked for us. Okay, So let's see what we're going to get. So in that case, we have 300,000, and then you divide by what? You divide by 1 plus the interest rate 0.86 divided by 12, and then to the power of 84, which is 7 multiplied by 12, that is 84 payments, and then subtract 1 into, and then you divide by the interest rate, which is 8.6, then divide 0.086 divided by 12. So this person, James must deposit an amount of 2,616.05 every month for him to accumulate an amount of 300,000 for the period of 7 years at an interest rate of 8.6% compounded monthly.